So let's take a look at indefinite integrals. Now I want to start off by talking about the difference between definite and indefinite integrals. Now in a definite integral, let's say you have the integral from a to b of f prime of x dx. This is obviously a definite integral because we have the bounds. In an indefinite integral, we don't have bounds. So it's just going to be the integral of f prime of x dx. Now indefinite integrals are a little bit easier to solve because all you have to do is anti-derive and then you add plus c, an arbitrary constant. So the integral of f prime of x is obviously f of x, and then because there are no bounds, because this is an indefinite integral, all you have to do is add plus c. And realize that when you derive f of x plus c, you get right back to f prime of x, because derivative of f of x is f prime, and derivative of a constant is 0. We just have to make sure that we add that constant always in an indefinite integral. Now for the next video in the playlist, in the Calculus 1 playlist, I will basically make an integral rules video, where I give out all the formulas for all integral rules that we need to know for calculus. Now for these next set of problems, let's go ahead and find the general indefinite integral. So for number 1, we have the integral of x to the negative 3/4 power dx. This is just the power rule for integrals, where when we integrate or when we find the antiderivative of x to the negative 3/4, we add 1 to the power, so negative 3/4 plus 1 or negative 3/4 plus 4/4 is positive 1/4, and divide by that same power, so divided by 1/4. Dividing by 1/4 is the same thing as multiplying by 4, so then we get 4x to the 1/4 power. And because this is an indefinite integral, we don't have to evaluate the bounds because there are no bounds, but we do have to add the plus c. So remember always when there's an indefinite integral to add the plus c, and that's the final answer. Now the good thing with this is you can also double check by deriving what we've got. So if you derive 4x to the 1/4 plus c, you'll get right back to x to the negative 3/4 power. Now for number 2, we have the integral of x cubed plus 6x plus 1 dx. So because there are pluses here separating x cubed, 6x, and 1, we can go ahead and take the integral of each individual term. So the integral of x cubed, once again using the power rule, add the power by 1, divide by the same power, x to the 4th over 4, plus the integral of 6x. Well, the 6 is just a constant, so we have 6x to the 1st. So when we integrate that, we add the power by 1, once again divide by that same power, and then we have plus the integral of 1, which the integral of 1 is going to be x, or 1 times x. Now simplifying here, we have x to the 4th over 4, or you can also rewrite it as, I'll rewrite it as 1/4x to the 4th, plus 6/2 is 3, so 3x squared, plus x, and because this is an indefinite integral, we have to add the plus c, and that's the final answer. Now for number 3, we have the integral of 1 minus t times 2 plus t squared dt. Now we can't necessarily integrate this at the moment, but sometimes we have to simplify what's inside the integral so it's easier to find the antiderivative. So what I'm going to go ahead and do is FOIL. So we have the integral of, well, 1 times 2 is going to be 2, and then we have 1 plus t squared, or 1 times t squared, which is positive t squared, minus t times 2, which is minus 2t, and then we have negative t times t squared, which is negative t cubed. And so now we can go ahead, if I put the dt there, now we can go ahead and use the power rule. So the integral of 2, now remember our variable we're integrating with respect to is t. So integral of 2 is going to be 2t. We have the integral of positive t squared, which is plus t cubed over 3. And then we have the integral of negative 2t, which is going to be negative 2t squared over 2, or negative t squared. And then we have the integral of negative t cubed, which is negative t to the 4th over 4. And then since this is an indefinite integral, we add the plus c, and that's the final answer. Now for number 4, we have the integral of 2 minus the square root of x, the entire thing squared, times dx. Now similar to the previous problem, I'm going to go ahead and FOIL. So 2 minus the square root of x squared is going to be 4 minus 4 times the square root of x, and then plus the square root of x squared, which is just x. So then I can go ahead and put that under the integral, multiply by dx, and then it's easier to integrate. So the integral of 4 is just going to be 4x. Now we have the integral of negative 4 times the square root of x. So I'm going to write that separately. The integral of negative 4. Now square root of x, I'll rewrite it as x to the 1/2 power. Now negative 4 is just a constant, so I can leave that outside. Now the integral of x to the 1/2 is going to be x to the 1/2 plus 1, which is 3/2, and then divided by 3/2, because once again we're using the power rule. Dividing by 3/2 is the same thing as multiplying by 2/3. So then 4 times 2 is 8. We do have the negative, so negative 8 over 3 x to the 3 halves. That's going to be the integral of negative 4 times the square root of x. So I'll rewrite that down once again. Negative 8 over 3 x to the 3 halves power. And then we have plus the integral of x, which is going to be x squared over 2, or 1/2 x squared. Now that we have found the antiderivative, because this is an indefinite integral, we add the plus c, and that's the final answer. Now for number 5, we have the integral of sine of x over 1 minus sine squared of x dx. Now the very first thing I'm going to do is try my best to simplify what's inside the integral as much as possible. Now using trig identities, remember that 1 minus sine squared is cosine squared. So I can rewrite it as sine of x over cosine squared of x. Now I'm actually going to go ahead and split this into 2 different fractions. So I'll rewrite one of the fractions as sine of x over one of the cosines, so cosine x, and then multiply by 1 over the other cosine of x. Now, sine of x over cosine of x is tangent of x, and then we have tangent of x times 1 over cosine, the reciprocal is secant of x. So I can rewrite now the integral as the integral of what we have simplified this entire thing down to, which is, I'll rearrange it as secant x times tangent x dx. Now remember, the integral of secant x tangent x is secant x, because we derive secant x to get to secant x tangent x. So we have secant x, and because this is an indefinite integral, we have secant x plus c.